December 17th, 1982. The Sea of Japan, approximately 70 nautical miles southeast of Vladivostok. USS Parsh was running at periscope depth through water so cold that ice crystals formed on the exterior hull plating. Commander Daniel McKinnon stood in the submarine's control room, studying a chart that officially didn't exist. The chart showed the approaches to Vladivostok Naval Base, home to the Soviet Pacific Fleet. Detailed bathymetric data, suspected minefield locations, patrol boat routes, radar coverage zones, all classified at levels beyond top secret, all obtained through previous missions that had risked American submarines and crews in operations that bordered on acts of war. McKinnon had been commanding Parsh for 8 months. He'd completed 3 intelligence collection missions in that time, each one more dangerous than the last. But Operation Winterwind was different. Winterwind required Parsh to penetrate Soviet territorial waters, approach within visual range of one of the USSR's most heavily defended naval facilities, collect intelligence that couldn't be obtained any other way, and withdraw before Soviet defenses could respond. The mission was so sensitive that even some Pentagon officials didn't know it was happening. If discovered, Parsha could be attacked. If forced to surface, an international incident would expose capabilities the United States had kept secret for 2 decades. But the intelligence value justified the danger. The Soviet Pacific Fleet was deploying new submarine classes, Delta IV ballistic missile boats, Oscar cruise missile submarines, Akula attack submarines quieter than anything the Soviets had built before. American intelligence needed to understand these capabilities. Satellite imagery provided some information, signals intelligence captured some data, but nothing replaced direct observation. Nothing matched the intelligence value of an American submarine operating inside Soviet waters, photographing vessels at close range, recording radar signatures, mapping defenses, collecting information that could mean the difference between victory and defeat if the Cold War turned hot. The operations officer, Lieutenant Commander Robert Tanner, approached with the latest sonar report. Master 1, a Soviet Grisha-class corvette, was conducting routine patrol approximately 28 nautical miles north of Parsh's position. Master 2, a Krivak-class frigate, was stationary near the harbour entrance, probably serving as a radar picket. Master 3 through Master 6 were diesel submarines, probably Kilo or Tango class, conducting their own training exercises southeast of the patrol zone. The acoustic picture was complex but manageable. Parsh carried the most sophisticated sonar systems ever installed on a submarine. The BQQ-5 suite could detect and classify contacts at ranges exceeding 40 nautical miles under favourable conditions. The TB-23 thin-line towed array trailing behind Parsh on a cable provided exceptional low-frequency detection. Together, they created an acoustic picture so detailed that sonar operators could identify individual Soviet vessels by their unique acoustic signatures. But all that technology was meaningless if Parsh was detected first. Soviet harbour defences included active sonar systems that could detect American submarines at ranges of several miles. Patrol boats carried dipping sonars. Helicopters could deploy sonobuoys. The water near Vladivostok was relatively shallow, less than 300 feet in many areas, which made hiding difficult. And winter weather meant ice coverage that could reveal submarine positions through anomalous ice patterns or pressure ridges. McKinnon reviewed the mission plan for perhaps the 100th time. Parsha would proceed northwest at 4 knots, minimizing propeller noise. At 20 nautical miles from the harbour, they'd reduce speed to 3 knots and go to ultra-quiet operations. All non-essential equipment secured, conversation forbidden, movement restricted. The submarine would become as silent as American engineering could achieve. At 10 nautical miles, they'd slow to 2 knots and raise the photonics mast, the periscope and sensor array that would capture the intelligence they'd come to collect. The final approach would take approximately 4 hours. 4 hours of creeping through defended waters, hoping Soviet sonar operators were tired or distracted, or simply not good enough to detect an American submarine that had no business being there. The withdrawal would be even more dangerous. Dawn reconnaissance flights would launch from Vladivostok at approximately 05:30 local time. Soviet maritime patrol aircraft would fly search patterns looking for exactly what Parch was doing. If a Tu-142 Bear or Il-38 May detected an American submarine near Soviet territorial waters, the political and military consequences would be severe. Parch had to complete the mission and withdraw to safe distance before Soviet air assets could locate her. Senior Chief Michael Reeves ran the sonar division. He'd been tracking Soviet submarines for 16 years, first on diesel boats, then on nuclear attack submarines, and finally on Parch during her conversion into a special mission submarine. Reeves had heard every type of Soviet vessel the Pacific Fleet operated. He could identify submarine classes by propeller blade count, recognize individual ships by their unique machinery signatures, and detect patrol boats before they detected him. His team was the best in the fleet. They had to be. Missions like Winterwind didn't allow for mistakes. Reeves monitored his displays with absolute concentration. The towed array showed Master 1 continuing her patrol pattern. The bow-mounted spherical array tracked Master 2 at the harbour entrance. The hull-mounted passive arrays listened for any change in the acoustic environment that might indicate Soviet forces responding to Parch's presence. So far, nothing suggested the Soviets knew an American submarine was approaching their most important Pacific naval base. At 18 nautical miles from Vladivostok, Mackinnon ordered speed reduced to 3 knots. Throughout Parch, systems went silent. The galley secured hot food service to eliminate cooking smells that could escape through ventilation systems. The engine room reduced circulation pumps to minimum flow. Crew members removed their shoes and moved on stocking feet. The submarine's reactor continued generating power, but every system that could be quieted was quieted. Parch became a ghost, creeping through the Sea of Japan toward one of the most heavily defended harbours in the Soviet Union. The water depth was decreasing. 280 feet, 240 feet, 210 feet. Parch was operating in relatively shallow water where detection was more likely. The submarine's massive hull created acoustic disturbances. Water displaced by the pressure hull generated subtle pressure waves. Even ultra-quiet operations produced some noise, and shallow water meant those sounds didn't dissipate into the deep ocean. They reflected off the bottom, creating acoustic paths that extended detection ranges. Mackinnon studied the fathometer reading and made continuous calculations in his head. Too shallow and Parch risked running aground. Too deep in these waters and they'd be operating near the bottom where manoeuvring was difficult. He maintained depth at 180 feet, giving clearance beneath the keel while staying below the thermal layer that helped mask the submarine's acoustic signature. At 12 nautical miles from Vladivostok, sonar detected a new contact. Master 7, classified as a probable Krivak-class frigate, was approaching from the northwest. Speed estimated at 15 knots, bearing 295 degrees. The contact was conducting what appeared to be routine operations, but its course would bring it uncomfortably close to Parch's track. Mackinnon considered his options. He could maintain course and hope Master 7 passed without detecting Parch. He could alter course to open distance, but any manoeuvre increased noise. Or he could halt all movement and let Master 7 pass. But that would delay the mission and risk missing the intelligence collection window. He chose to maintain course. Parch continued northwest at 3 knots while the Soviet frigate approached from the side. The geometry was unfavourable. Master 7 would pass within approximately 4 nautical miles of Parch's position, close enough that active sonar could detect the American submarine, close enough that a sharp sonar operator might pick up Parch's faint signature even on passive systems. Reeves watched the waterfall display showing Master 7's acoustic signature. The Krivak's propellers created a distinctive pattern, 5 blades on each shaft, turning at specific RPM that created harmonic frequencies Reeves had memorized years ago. The ship's reduction gears produced a higher frequency whine. Pumps and generators added their own contributions to the overall signature. Together, they painted an acoustic picture of a Soviet surface combatant operating at moderate speed in home waters. The range was closing. 4.2 nautical miles. 4.0. 3.8. Parsh maintained course and speed, making minimal noise, hoping the Soviet frigate's sonar operators weren't alert enough or skilled enough to detect an American submarine that was violating their territorial waters. At 3.4 nautical miles, Master 7's propeller noise changed. The blade rate increased, speed increasing. The frigate was accelerating. McKinnon felt his pulse quicken. Had they been detected? Was the Soviet vessel responding to a sonar contact? Or was this simply routine operations, a speed change unrelated to Parsh's presence? Reeves analyzed the acoustic data. The bearing to Master 7 remained constant. No aspect change. The frigate wasn't turning toward Parsh. Whatever had caused the speed increase, it didn't appear to be a response to detecting an American submarine. The frigate continued on her original course at higher speed, passing through Parsh's operating area and proceeding southeast toward the open ocean. The range opened. 4 nautical miles. 5. 6. Master 7 departed the area, unaware that an American submarine had been less than 4 miles away. McKinnon exhaled slowly. One threat passed, many more ahead. At 10 nautical miles from Vladivostok Naval Base, Parsh slowed to 2 knots. This was the final approach, the most dangerous phase of the mission, the phase where detection was most likely and consequences most severe. The photonics mast officer, Lieutenant James Kellerman, prepared his equipment. The photonics mast was a technological marvel, a non-penetrating optical periscope that used digital imaging rather than traditional lenses and mirrors. It could capture high-resolution photographs in low-light conditions. It could record video. It could intercept radar signals and communications. And unlike traditional periscopes, it had a minimal radar cross-section that made detection more difficult. Kellerman had trained for months on the system. He knew its capabilities and limitations. He understood how to maximize image quality while minimizing exposure time above the surface. He'd practiced in simulators and during training exercises. But this was different. This was operational. This was inside Soviet territorial waters, approaching a defended harbor, collecting intelligence that would be analyzed by Navy intelligence, CIA, National Security Agency, and possibly the President himself. At 9 nautical miles, McKinnon ordered the photonics mast raised. The mechanism extended upward through the submarine's sail, breaking the surface approximately 30 feet above the submerged hull. Kellerman's display illuminated with the view from above, darkness, the Sea of Japan at night, minimal moonlight, overcast skies, perfect conditions for covert operations. He adjusted the camera's sensitivity and began scanning the horizon. At first, nothing but ocean. Then, lights, distant and faint, but unmistakable. Vladivostok, the massive Soviet naval base spread across multiple harbors and facilities, home to dozens of surface combatants, submarines, support vessels, and infrastructure that supported the Pacific Fleet's operations throughout the Far East and Pacific Ocean. McKinnon ordered Parsh to maintain course toward the harbor entrance. The submarine crept forward at 2 knots, making minimal noise, presenting minimal signature, hoping Soviet defenses weren't alert enough to detect an American submarine approaching their most important Pacific base in the middle of the night. Kellerman adjusted the photonics mast camera to maximum magnification. The lights of Vladivostok grew clearer. Individual vessels became visible. Destroyers tied alongside piers, submarines in refit, cranes and industrial facilities, shore installations with radars rotating, guard towers with searchlights. The infrastructure of Soviet naval power concentrated in one location. At 8 nautical miles, Kellerman began capturing images. High-resolution photographs of every visible vessel. Video recordings of radar rotation patterns. Electronic intercepts of communications and radar signals. The intelligence collection phase had begun. Each image was automatically stored on encrypted drives. Each intercept was recorded on magnetic tape. Each piece of information would be analyzed by specialists who could identify submarine classes by conning tower configurations, determine vessel capabilities by weapons loadouts, and assess Soviet naval readiness by observing which ships were operational versus in maintenance. Pasha continued approaching. 7 nautical miles, 6.5. The mission plan called for reaching a minimum distance of 5 nautical miles, close enough for detailed photography, but far enough to retain some margin for escape if detected. At 6 nautical miles, sonar detected a new threat. Master 8, classified as a Grisha-class corvette, was departing Vladivostok harbor. Speed estimated at 12 knots. Course 170, heading almost directly toward Pasha's position. This was the nightmare scenario. A Soviet patrol boat on an intercept course while Pasha was conducting intelligence collection operations inside territorial waters. McKinnon made his decision instantly. Secure the mast, maintain depth and course, continue mission. The photonics mast retracted. Kellerman's display went dark. Pasha continued forward at 2 knots while the Soviet corvette approached at 12. The geometry was unfavorable. If Master 8 maintained course and speed, she'd pass within 2 nautical miles of Pasha's position. Well within active sonar detection range. Possibly within passive sonar. Range if the Soviet operators were skilled and Pasha made any mistake that increased her acoustic signature. Reeves monitored Master 8 with intense focus. The corvette's acoustic signature was clear and distinctive. Gas turbine engines producing a high-frequency whine. Propeller cavitation from high-speed operation. Hull-mounted sonar transducers that could potentially detect Pasha if employed. The bearing changed slightly. Master 8 was adjusting course, turning to starboard. The new course would take the corvette east of Pasha's position, rather than directly toward it. A routine patrol pattern, not a response to detecting an American submarine. The range to Master 8 continued decreasing despite the course change. 2.8 nautical miles, 2.6, 2.4, inside the range where Soviet active sonar could detect Pasha if employed. McKinnon stood motionless in the control room. Every instinct urged him to maneuver away from the threat, but maneuvering meant increased noise. Turning meant the submarine's broadside would present a larger sonar target. The best chance of remaining undetected was to continue slowly on course, maintaining ultra-quiet operations, hoping the Soviets didn't know to look for an American submarine in their own territorial waters. Master 8 passed through closest point of approach at 2.3 nautical miles. The corvette continued on her patrol route, heading east away from Vladivostok, unaware that an American submarine was less than 3 miles away, collecting intelligence on Soviet Pacific Fleet capabilities. The range opened. 2.6 miles, 3, 3.5. The threat passed. McKinnon ordered the photonics mast raised again. Kellerman's display illuminated. The lights of Vladivostok reappeared. Pasha resumed intelligence collection operations at 5.8 nautical miles from one of the Soviet Union's most important naval installations. For the next 90 minutes, Kellerman worked systematically. He photographed every visible vessel in multiple harbors. He recorded radar rotation patterns from shore installations. He documented vessel configurations, weapons loadouts, and operational status. He captured images of submarines in dry dock undergoing maintenance, revealing hull configurations and propeller designs that American intelligence had never photographed before. He observed patrol boat routines and harbor security procedures. He documented everything the photonics mast could capture from a submarine operating inside Soviet territorial waters at night. The intelligence value was extraordinary. Satellite imagery could show vessels in harbor, but not with this level of detail. Signals intelligence could intercept communications, but not with this visual context. Only a submarine approaching to close range in darkness could collect the comprehensive intelligence that would inform American naval planning for years to come. At 03:15 local time, McKinnon ordered the mission terminated. Pasha had collected the required intelligence. Remaining longer increased risk without proportionate benefit. The submarine had been inside Soviet territorial waters for nearly 4 hours. Dawn reconnaissance flights would launch in approximately 2 hours. Time to withdraw. Kellerman secured the photonics mast. The mechanism retracted below the surface, and Parsh's most vulnerable sensor was safely stowed. Mackinnon ordered course change to 135, heading southeast away from Vladivostok and back toward international waters. Speed increased to 5 knots. Still quiet by operational standards, but faster than the approach phase. Time mattered now. Distance mattered. Getting clear of Soviet territorial waters before dawn, reconnaissance flights could detect an American submarine that shouldn't exist in this location. Parshe cleared Soviet territorial waters at 0442 local time, 48 minutes before scheduled dawn reconnaissance flights from Vladivostok. Mackinnon maintained increased speed and continued southeast, opening distance from the Soviet coast. The immediate danger had passed, but the mission wasn't complete until Parshe reached the safe operating area where she could transmit her intelligence collection back to Navy headquarters and CIA. At 100 nautical miles from Vladivostok, Mackinnon authorized a communications window. The submarine rose to periscope depth, extended her radio masts, and transmitted an encrypted burst message lasting less than 8 seconds. Mission successful. Intelligence collected. No detection. Returning to station. The message would be received by a satellite communications relay, decrypted at multiple secure facilities, and distributed to intelligence analysts who would spend weeks examining every photograph, every radar intercept, every piece of information Parshe had collected during her penetration of Soviet territorial waters. Some of those analysts would be Navy intelligence officers focused on Soviet Pacific Fleet capabilities. Others would be CIA specialists tracking strategic weapons deployments. NSA signals intelligence experts would analyze the radar and communications intercepts. Defense Intelligence Agency personnel would assess Soviet readiness and operational patterns. And somewhere in the chain, senior officials would brief the president on what American submarines were learning inside Soviet harbors. The intelligence Parshe collected during Operation Winterwind would be compared against previous missions. Analysts would track changes in Soviet deployments. New submarine classes would be identified and catalogued. Weapons systems would be assessed. Harbor defenses would be mapped. Patrol patterns would be understood. The accumulated knowledge would inform American strategic planning, influence weapons development, shape operational doctrine, and provide early warning if Soviet naval forces were preparing for conflict. But Mackinnon knew none of those details. His job was to execute the mission, collect the intelligence, and return his submarine and crew safely. The analysis and strategic implications were someone else's responsibility. He focused on the immediate tactical situation. Parshe was clear of immediate danger, but still operating in waters where Soviet submarines and patrol aircraft could detect her. The submarine would remain at heightened alert until reaching the safe operating area approximately 300 nautical miles from the Soviet coast. At 0720, sonar detected aircraft noise. A Soviet maritime patrol aircraft, probably a Tu-142 Bear based on the acoustic signature, was conducting search operations northwest of Parshe's position. The aircraft was too distant to pose immediate threat, but its presence confirmed that Soviet forces were actively searching the approaches to Vladivostok. Standard procedure after a patrol boat reported suspicious sonar contacts, or routine operations unrelated to Parshe's mission. Impossible to know which. Mackinnon ordered depth increased to 300 feet. Deeper water provided more protection against airborne detection. The submarine's acoustic signature was harder to detect at depth, and if the Soviets deployed active sonar buoys, the increased depth provided more reaction time before Parshe would need to maneuver. The Tu-142 continued its search pattern for 90 minutes before departing to the north. Sonar tracked the aircraft until it disappeared beyond detection range. No indication the Soviets had detected Parshe. No emergency transmissions. No changes in patrol patterns. The Americans had penetrated Soviet territorial waters, collected intelligence on their most important Pacific naval base, and withdrawn without detection. Operation Winterwind had succeeded. Pache reached the safe operating area at 1400 hours local time. McKinnon authorized stand-down from ultra-quiet operations. Crew members could move normally. The galley resumed hot food service. Normal watch rotations replaced extended duty periods. The submarine returned to routine patrol operations, while intelligence analysts thousands of miles away began examining the information Pache had risked everything to collect. Lieutenant Commander Tanner compiled the mission report. Time penetrating territorial waters, 3 hours, 47 minutes. Closest approach to Soviet naval facility, 5.2 nautical miles. Number of vessels photographed, 43. Number of radar intercepts, 17. Number of communications intercepts, 29. Number of times detected by Soviet forces, 0. The statistics told only part of the story. They didn't capture the tension in the control room as Soviet patrol boats passed within miles of Pache's position. They didn't reflect the concentration required to navigate minefields without charts. They didn't convey the professional skill of sonar operators who detected threats before those threats detected the submarine, and they certainly didn't communicate the risk that every man aboard had accepted. That discovery could mean attack, that surfacing could create an international incident, that missions like Winterwind existed in a grey area between intelligence collection and acts of war. 3 months later, in March 1983, USS Pache received orders for a second penetration mission. This time the target was Petropavlovsk, the Soviet Pacific Fleet's submarine base on the Kamchatka Peninsula. Petropavlovsk was even more heavily defended than Vladivostok. The harbour was surrounded by mountains that funneled approach routes into predictable channels. Minefields protected the entrance. Patrol boats operated continuously. And unlike Vladivostok, which was a general-purpose naval base, Petropavlovsk specialized in ballistic missile submarines. The vessels home-ported there carried nuclear weapons and represented the Soviet Union's strategic deterrent. Collecting intelligence on those submarines was a strategic priority. Understanding their capabilities, their operational patterns, their readiness. That information could influence American strategic planning at the highest levels. But approaching Petropavlovsk was extraordinarily dangerous. The confined approaches meant limited maneuvering room. The mountainous terrain created acoustic anomalies that made sonar detection unpredictable, and the strategic importance of the base meant Soviet defenses were especially alert. Commander McKinnon studied the intelligence briefing materials in his stateroom. Charts showing the approaches to Petropavlovsk, satellite imagery of the harbour and facilities, signals intelligence reports on patrol boat schedules and radar coverage. Previous mission reports from submarines that had operated near, but not inside, Soviet territorial waters around the Kamchatka Peninsula. The mission plan for this operation was even more aggressive than Winterwind. Pache would approach within 3 nautical miles of the harbour entrance, close enough to photograph submarines in detail, close enough to capture hull numbers and identify individual vessels, close enough to document modifications and assess capabilities that satellite imagery couldn't resolve. The risk assessment was brutal. If detected, Pache could be forced to surface. Soviet forces might attempt to board the submarine. At minimum, an international incident would expose American intelligence collection capabilities that had been secret for decades. At worst, Soviet forces might attack before confirming the submarine's nationality. International law permitted nations to defend their territorial waters against military intrusion. A Soviet destroyer or patrol boat that detected an unidentified submarine approaching Petropavlovsk would be justified in employing weapons. Depth charges, torpedoes, anti-submarine rockets. The weapons existed, and Soviet forces were trained to use them. Whether they would actually fire on an American submarine was uncertain, but the possibility was real enough that every man aboard Pache understood the stakes. McKinnon briefed his officers on the mission. Lieutenant Commander Tanner would coordinate the intelligence collection. Lieutenant Kellerman would operate the photonics mast and sensors. Senior Chief Reeves would manage sonar operations and threat detection. Each position was critical. Each role required perfect execution, and each man knew that mistakes could be fatal. The submarine departed the safe operating area on March 19, 1983. She proceeded northwest toward the Kamchatka Peninsula at standard patrol speed, conserving battery power and minimizing acoustic signature. The voyage to the operating area required 4 days of transit through international waters, where Soviet submarines and maritime patrol aircraft operated continuously. On March 23, Pasha reached the initial point for the approach to Petropavlovsk, 100 nautical miles east of the Kamchatka Peninsula. Deep water, no immediate threats. McKinnon ordered the submarine to periscope depth for a final communications check before beginning the penetration mission. The radio mast extended and received an encrypted message from Pacific Fleet headquarters. Weather conditions near Petropavlovsk had deteriorated. A storm system was moving through the area with high winds and heavy seas. Surface visibility was reduced, but underwater conditions were actually favorable. The storm created surface noise that masked submarine acoustic signatures. The message concluded with authorization to proceed at commander's discretion. McKinnon evaluated the situation. Storm conditions made surface operations more difficult, which complicated the intelligence collection mission. But the acoustic masking was a significant advantage. Soviet sonar systems would have more difficulty detecting Pasha in the noisy conditions created by the storm. He decided to proceed. Pasha descended to 300 feet and began the approach to Petropavlovsk. The submarine maintained 6 knots initially, covering distance while conditions remained favorable. At 50 nautical miles from the Soviet coast, speed reduced to 4 knots. At 30 miles, ultra-quiet operations began. All the procedures from Operation Winterwind were repeated. Secure non-essential systems, restrict movement, minimize noise, transform the submarine into a ghost that could penetrate Soviet defenses without detection. Sonar conditions were complex. The storm created surface noise that masked distant contacts, but also made classification more difficult. Reeves and his team worked to separate biological contacts from mechanical signatures, distinguish Soviet vessels from commercial shipping, and identify threats before those threats could detect Pasha. At 25 nautical miles from Petropavlovsk, sonar detected multiple contacts. Master 1 through Master 4 were classified as probable patrol boats conducting routine operations near the harbour entrance. Master 5 was a submarine, classification uncertain, operating submerged approximately 15 nautical miles south of the harbour. Master 6 was a surface combatant, probably a destroyer or large frigate, stationary near the harbour approaches. The acoustic picture suggested normal defensive operations, not a heightened alert status. The Soviets didn't appear to be expecting an American submarine to penetrate their territorial waters. McKinnon studied the tactical situation. 6 known contacts, unknown number of additional threats that sonar hadn't detected yet. Minefields that couldn't be seen, but were certainly present based on intelligence reporting. Radar coverage from shore installations that would detect a periscope or mast if exposed too long. And storm conditions that helped mask Pasha's approach, but also made navigation more challenging. At 15 nautical miles, Pasha slowed to 3 knots. The final approach phase began. The submarine crept toward Petropavlovsk, while storm conditions churned the surface, and Soviet patrol boats conducted their defensive operations unaware that an American submarine was approaching their most important strategic submarine base. The water depth decreased as Pasha approached the continental shelf surrounding Kamchatka. 400 feet, 320, 280. The submarine was entering shallow water where acoustic detection was more likely and maneuvering was more constrained. McKinnon maintained depth at 200 feet, balancing the need for stealth against the danger of running aground in unfamiliar waters. At 12 nautical miles, sonar detected a new contact. Master 7, classified as a Grisha-class corvette, was approaching from the north at high speed. Estimated speed 18 knots. Course 180, heading directly south. The course would bring Master 7 within 5 nautical miles of Pasha's position, unless one vessel or the other changed course. Mackinnon ordered course adjustment to starboard, opening lateral separation while maintaining general approach toward Petropavlovsk. Pasha turned gradually, minimizing the noise associated with rudder movement and course changes. The bearing to Master 7 changed, indicating successful lateral separation. The Soviet corvette continued south, passed east of Pasha's position, and proceeded toward the open ocean. Another threat bypassed. At 8 nautical miles from Petropavlovsk harbor entrance, Mackinnon ordered speed reduced to 2 knots. The photonics mast prepared for deployment. Lieutenant Kellerman reviewed his equipment and sensors. Everything operational, everything ready for the intelligence collection phase. At 7 nautical miles, Pash rose to periscope depth. The photonics mast extended above the surface into storm conditions. Kellerman's display showed darkness, wind-driven spray, and limited visibility. The storm was affecting surface conditions more than anticipated, but through breaks in the weather, lights were visible. Petropavlovsk, the Soviet Pacific Fleet's ballistic missile submarine base. Mackinnon ordered the submarine to maintain course directly toward the harbor entrance. Pash continued forward at 2 knots, while Kellerman worked to capture images through difficult weather conditions. The storm reduced visibility, but also reduced the risk of visual detection. Soviet lookouts would have difficulty spotting a periscope in these conditions. At 6 nautical miles, visibility improved briefly as the storm passed through different intensity phases. Kellerman captured a series of high-resolution photographs showing the harbor entrance, shore installations, and several vessels visible in the outer harbor. One image showed what appeared to be a Delta IV ballistic missile submarine alongside a pier. The distinctive raised missile compartment was clearly visible. Intelligence analysts would study that photograph for weeks, measuring dimensions, assessing capabilities, comparing against previous imagery to determine modifications or new features. Another image captured a submarine in dry dock. The vessel's propeller was visible, revealing blade count and diameter, information that would help American sonar operators identify this specific submarine by its acoustic signature in future encounters. Additional photographs showed shore facilities, radar installations, patrol boats, and the general layout of the base. Every image added to the intelligence picture. Every piece of information helped American strategists understand Soviet capabilities and intentions. At 5 nautical miles, sonar detected an urgent change. Master 6, the surface combatant that had been stationary near the harbor, was accelerating. Speed increasing from 0 to 15 knots in less than 2 minutes. Course change to 105, heading toward the open ocean, toward Pash's approximate location. Mackinnon made an immediate decision: secure the mast, maintain depth, maintain course, continue ultra-quiet operations. The photonics mast retracted. Pash maintained 2 knots on a steady course, while the Soviet surface combatant accelerated to 15 knots on what appeared to be an intercept heading. Had Pash been detected? Was Master 6 responding to a sonar contact? Or was this unrelated to the American submarine, a routine sortie or response to some other stimulus? Impossible to know. Reeves analyzed Master 6's acoustic signature. The vessel was a Krivak-class frigate based on propeller characteristics and machinery noise. The ship carried anti-submarine weapons including depth charge racks and rocket launchers. If the Krivak had detected Pash and was responding with hostile intent, the situation was extremely dangerous. The geometry was unfavorable. Master 6 was on a course that would bring it within 3 nautical miles of Pash's position in approximately 12 minutes. Well, within active sonar range. Within weapons range if the Soviets chose to attack. Mackinnon considered his options. He could continue on course and hope Master 6 was conducting routine operations. He could alter course to open distance, but maneuvering would increase acoustic signature. He could increase speed and attempt to clear the area, but higher speed meant more noise and greater risk of detection. Or he could conduct emergency deep dive, descending to maximum depth and using the ocean floor to break sonar lock. But the water here was only 280 feet deep with uncertain bottom conditions. He chose to maintain course at 2 knots, holding ultra-quiet operations, betting that Master 6 was not responding to Parsh but conducting some other mission. The Krivak continued on course, 15 knots, bearing 295 degrees from Parsh's position. Range decreasing, 4.2 nautical miles, 3.8. At 3.5 nautical miles, the Krivak's acoustic signature changed. The propeller noise decreased, speed dropping. The frigate was slowing. McKinnon watched the sonar displays with intense focus. Was Master 6 preparing to conduct sonar search? Had they detected something and were now slowing to investigate? Or was this simply coincidental with Parsh's presence? The Krivak slowed to approximately 5 knots and appeared to be conducting a search pattern. Systematic course changes, speed variations. The behavior was consistent with anti-submarine operations. But whether they were searching for Parsh specifically or conducting routine training was impossible to determine. For 30 minutes, the Soviet frigate conducted search operations while Parsh remained motionless at 2 knots, maintaining ultra-quiet, hoping the Soviets weren't good enough or lucky enough to detect an American submarine operating inside their territorial waters during a storm. At 0340 local time, the Krivak secured from search operations and resumed course toward open ocean. Speed increased to 12 knots. The vessel departed the area heading southeast, away from Parsh's position. The range opened. 4 nautical miles. 5, 6. The immediate threat passed. Whether Master 6 had detected something and lost contact, or whether the search had been unrelated to Parsh, McKinnon would never know. But the submarine had survived another close encounter with Soviet defensive forces. At 0355, McKinnon ordered the photonics mast raised again. Kellerman's display illuminated with the view from above the surface. The storm had moderated slightly. Visibility improved. The lights of Petropavlovsk were clearly visible at 5.3 nautical miles. Kellerman resumed intelligence collection operations. For the next 60 minutes, he captured additional photographs and sensor data. Submarines in the harbour, surface vessels alongside piers, shore facilities and defensive, installations, radar rotation patterns. Every piece of intelligence that could be collected from a submarine operating at the edge of Soviet territorial waters during a storm at night. At 0500, McKinnon ordered mission termination. Parsh had collected extensive intelligence. Remaining longer after the Krivak search operations would be pushing luck beyond reasonable limits. The submarine secured the photonics mast and turned southeast, withdrawing from the Petropavlovsk operating area toward international waters. The return transit proceeded without incident. Dawn reconnaissance flights launched from Petropavlovsk at 0545, but by then, Parsh was 20 nautical miles from the coast, an increasing distance. The submarine cleared Soviet territorial waters at 0632. McKinnon maintained elevated speed until reaching the safe operating area at 100 nautical miles from Kamchatka. At that point, Parche transmitted her success message. Intelligence collected, no detection. Returning to station. The photographs and sensor data from the Petropavlovsk mission were analyzed in detail. The images of the Delta IV submarine provided information about Soviet strategic systems. The dry dock photographs revealed propeller designs. The shore facility images updated intelligence databases on Soviet Pacific Fleet infrastructure. And the radar intercepts provided information about defensive systems protecting one of the USSR's most important naval installations. The success of the Vladivostok and Petropavlovsk missions established a template for even more aggressive intelligence collection operations. Between 1983 and 1988, American special mission submarines conducted dozens of penetrations into Soviet territorial waters. Each mission refined tactics. Each operation expanded the intelligence picture, and each successful penetration demonstrated that American submarine technology and crew skill could defeat Soviet defensive systems. But the missions also demonstrated the limits of intelligence collection by penetration. The operations required perfect execution. They depended on Soviet defenses being less capable than American stealth. They assumed that political leadership in both nations would exercise restraint if an American submarine was detected inside Soviet waters. And they carried the constant risk that one mistake, one equipment failure, one moment of bad luck could create an international incident with consequences neither side could fully predict. In August 1985, USS Richard B. Russell received orders for a mission even more sensitive than Winterwind. The target was Polyarny, the Northern Fleet submarine base near Murmansk, above the Arctic Circle. Polyarny was home to the Soviet Union's most capable ballistic missile submarines and attack boats. The base supported operations in the Norwegian Sea, the Greenland-Iceland-UK Gap, and potentially the North Atlantic in wartime. Collecting intelligence on vessels homeported at Polyarny was a strategic intelligence priority, but the approaches to Murmansk were even more heavily defended than Vladivostok or Petropavlovsk. Multiple patrol boat squadrons, shore-based radar installations, maritime patrol aircraft flying continuous search patterns, and ice conditions that made submarine operations extraordinarily difficult. Commander Thomas Harrington commanded Richard B. Russell. He had completed 4 previous special missions in the Atlantic and Norwegian Sea. His crew was experienced in operations near Soviet forces. His submarine carried the latest sonar systems, communications equipment, and sensors. But Polyarny was different. The Arctic environment created unique challenges. Ice cover changed acoustic propagation. Temperature gradients affected sonar performance. Navigation was more difficult, and Soviet Northern Fleet forces were among the most capable adversaries in the world. Harrington reviewed the mission plan in his stateroom, while Richard B. Russell transited submerged toward the Norwegian Sea. The submarine would approach Polyarny from the northwest, using a route that avoided known patrol areas. The approach would be conducted under ice cover where possible, using the ice as concealment against Soviet radar and visual detection. At 10 nautical miles from Polyarny, Russell would rise to periscope depth and begin intelligence collection operations. The submarine would photograph vessels in harbor, record radar signatures, intercept communications, and document everything that could be observed from outside Soviet territorial waters. The key difference from previous Winterwind-style missions was that Russell would not penetrate as deeply into territorial waters. The defenses around Polyarny were too capable, the risk of detection too high. Instead, the mission would rely on advanced sensors and cameras that could collect intelligence from greater distances. The photonics mast on Russell carried cameras with longer focal lengths than Parcher had used at Vladivostok. Electronic surveillance equipment could intercept signals at extended ranges, and intelligence analysts had provided specific collection requirements that focused on vessels visible from the harbor approaches rather than requiring close-range penetration. On August 14, 1985, Richard B. Russell reached the initial point for the Polyarny mission. The submarine was operating approximately 70 nautical miles north of the Kola Peninsula. Ice coverage was approximately 30%. Enough open water for periscope operations, but enough ice to provide tactical advantages. Harrington ordered the submarine to proceed south toward Polyarny at 6 knots. The sonar picture showed multiple contacts. Soviet submarines conducting training exercises, surface vessels on patrol, fishing boats and commercial shipping. The waters near Murmansk were crowded with activity. Separating military threats from civilian traffic required constant attention from the sonar division. Senior Chief William Brennan ran sonar operations on Russell. He had tracked Soviet Northern Fleet submarines for 12 years. He knew the acoustic signatures of every major class. He could identify individual vessels by their unique machinery noise. His team maintained contact on 17 different targets as Russell approached the Kola Peninsula. At 40 nautical miles from Polyarny, Harrington ordered speed reduced to 4 knots. Ultra-quiet operations began. The submarine transitioned from standard patrol routine to the heightened alert status required for operations near Soviet defensive forces. At 25 nautical miles, sonar detected a particularly concerning contact. Master 1, classified as an Akula-class attack submarine, was operating submerged approximately 18 nautical miles east of Russell's position. The Akula was one of the quietest submarines in the Soviet inventory. Some intelligence estimates suggested Akula boats were nearly as quiet as American Los Angeles-class submarines. If the Soviet commander was skilled and his sonar operators alert, the Akula could potentially detect Russell before Russell detected the Akula. Brennan monitored Master 1 with intense focus. The Akula's signature was faint. Propeller noise barely above ambient ocean sound. Machinery noise suppressed by acoustic isolation. This was a capable opponent, operating in home waters with every tactical advantage. Harrington adjusted Russell's course to open distance from Master 1, while continuing general approach toward Polyarny. The submarine turned gradually to port, minimizing the noise associated with course changes. The bearing to Master 1 changed slightly. Range remained approximately 18 nautical miles. The Soviet submarine appeared to be conducting routine patrol operations, not actively hunting for American submarines. At 15 nautical miles from Polyarny, Harrington ordered speed reduced to 3 knots. The photonics mast prepared for deployment. The electronic surveillance equipment activated. Russell was approaching the intelligence collection phase. At 12 nautical miles, sonar detected surface contacts approaching from the south. Master 8 through Master 11, classified as probable patrol boats, were conducting defensive operations near the harbour approaches. Speed estimated at 15 knots. Courses varying but generally northward. The patrol boats were operating in a search pattern, systematically covering the approaches to Polyarny. Standard defensive procedure for protecting a strategic submarine base. Harrington studied the tactical picture. Multiple Soviet submarines operating nearby. Patrol boats conducting active searches. Unknown additional threats that hadn't been detected yet, and ice conditions that complicated navigation and communications. He made his decision. Continue mission. Proceed to collection point. Execute intelligence operations and withdraw before Soviet forces could respond. At 10.2 nautical miles from Polyarny harbour entrance, Russell rose to periscope depth. The photonics mast extended above the surface. The electronic surveillance officer, Lieutenant David Chen, activated his equipment. His displays illuminated with signals. Soviet radar emissions, communications intercepts, navigation beacons. The electromagnetic spectrum was crowded with Soviet military activity. Chen began recording everything: radar signal characteristics, frequency patterns, pulse repetition rates, modulation schemes, all the technical parameters that would allow American electronic warfare systems to identify, classify, and potentially jam Soviet radars if conflict occurred. The photonics mast operator, Lieutenant Sarah Morrison, adjusted her cameras to maximum magnification. Through breaks in the ice cover, lights were visible. Polyarny, the massive Soviet submarine base. Morrison began capturing images. High-resolution photographs of the harbour, vessels at piers, submarines in refit, support facilities. Everything visible from 10 nautical miles distance through Arctic conditions. One photograph showed a Typhoon-class ballistic missile submarine, the largest submarine class in the world. The massive vessel was alongside a pier with what appeared to be a missile loading operation in progress. Intelligence analysts would study that image to understand Soviet strategic weapons handling procedures. Another photograph captured 3 Akula-class attack submarines tied alongside each other. The configuration of their sails and the details of their hull coatings would provide information about modifications and capabilities. Additional images documented Sierra-class submarines, Victor III boats, patrol vessels, and infrastructure that supported the Northern Fleet's operations throughout the Arctic and North Atlantic. For 90 minutes, Russell conducted intelligence collection operations, while Soviet patrol boats searched nearby, and Soviet submarines conducted their own training exercises. The Americans remained undetected at the edge of Soviet territorial waters, collecting information that couldn't be obtained any other way. At 03:30 local time, Harrington ordered mission termination. Russell had collected extensive intelligence. The risk of continuing operations outweighed potential additional information. The photonics mast retracted. The electronic surveillance equipment secured. Russell descended to 300 feet and turned northwest, withdrawing from the Polyarny operating area. The return transit proceeded carefully. Master 1, the Akula-class submarine, was still operating approximately 20 nautical miles east of Russell's position. The patrol boats continued their search patterns. Soviet maritime patrol aircraft were likely conducting their own operations above the surface. Harrington maintained ultra-quiet operations until Russell was 50 nautical miles clear of the Kola Peninsula. Only then did he authorize stand-down to normal patrol routine. The submarine reached the safe operating area and transmitted her success message. Intelligence collected. No detection. Returning to station. The photographs and electronic intelligence from the Polyarny mission filled gaps in American understanding of Soviet Northern Fleet capabilities. The images of the Typhoon showed weapons handling procedures. The Akula photographs revealed configuration details. The radar intercepts provided technical parameters for electronic warfare systems. And the accumulated intelligence helped American strategic planners understand the threat posed by Soviet submarine forces operating from Arctic bases. Between 1985 and 1988, additional Winterwind-style missions were conducted by both Pasha and Russell. Some targeted Vladivostok again, others focused on Petropavlovsk. A few penetrated waters near Soviet submarine bases on the Pacific coast and in the Arctic. Each mission collected intelligence that informed American strategic planning. Each operation demonstrated American capability to penetrate Soviet defensive systems. And each successful mission increased confidence that American submarines could operate inside Soviet waters if required during conflict. But the missions also carried increasing risk. Soviet defensive capabilities were improving. New patrol boats with better sonar systems were being deployed. Defensive procedures were being refined. And some intelligence reporting suggested that Soviet forces were aware that American submarines were conducting aggressive intelligence collection operations, even if they couldn't detect the submarines during specific missions. The political context was also changing. Mikhail Gorbachev had become General Secretary of the Soviet Communist Party in 1985. His policies of glasnost and perestroika were transforming Soviet society. Arms control negotiations were producing agreements that reduced strategic weapons. The Cold War was entering a new phase where confrontation was being replaced by cautious cooperation. In that environment, aggressive submarine intelligence collection operations carried different risks. Detection could undermine arms control negotiations. An incident could provide ammunition to Soviet hardliners who opposed Gorbachev's reforms. And the intelligence value of the missions had to be balanced against the political consequences if operations were exposed. In 1988, senior Navy leadership ordered a comprehensive review of special mission submarine operations. The review examined the intelligence value of Winterwind-style penetration missions. It assessed the operational risks. It evaluated alternatives including long-range sensors, satellite imagery, and signals intelligence collection from safer distances. The conclusion was that penetration missions remained valuable, but should be conducted more selectively. Operations would continue when the intelligence requirement justified the risk, but routine penetrations would be reduced. More emphasis would be placed on long-range collection using advanced sensors, and political considerations would weigh more heavily in authorization decisions. Commander McKinnon, who had led the first Winterwind mission in 1982, attended the final briefing on the policy changes. He understood the logic. Technology was improving. Satellites could collect some information that previously required submarine penetration. Electronic surveillance equipment had longer ranges, and the political environment was different from the early 1980s, when Cold War tensions justified aggressive intelligence operations. But McKinnon also understood what would be lost. Nothing replaced direct observation. Satellites couldn't capture the level of detail that a submarine at close range could photograph. Electronic surveillance couldn't provide the comprehensive intelligence picture that human operators observing Soviet naval bases could compile. And some intelligence simply required risk to obtain. The missions that McKinnon and commanders like Thomas Harrington had conducted between 1982 and 1988 collected intelligence that shaped American strategic planning throughout the final decade of the Cold War. The photographs of Soviet submarines informed weapons development. The radar intercepts enabled electronic warfare systems. The comprehensive intelligence picture helped American planners understand Soviet capabilities and intentions. Those missions also demonstrated something more fundamental. They proved that American submarines and crews could operate successfully in the most dangerous environments against capable adversaries. They showed that technology, training, and professional skill could overcome defensive systems. And they established that American forces could conduct operations that the Soviets believed were impossible. When the Cold War ended in 1991, many aspects of submarine intelligence operations remained classified. The existence of special mission submarines was acknowledged, but details remained secret. The specific missions conducted by Posh, Russell, and other boats remained in classified archives, and the men who had risked their lives penetrating Soviet harbors at night couldn't discuss their operations publicly. But within the submarine community, Operation Winterwind and similar missions were understood as examples of the extraordinary risks that submarines had taken to collect intelligence critical to national security. The missions demonstrated courage, they required professional excellence, and they showed that American submarines could conduct operations that existed at the very edge of what international law and political reality would tolerate. Years later, some details of the operations were declassified. Navy historians documented the special mission submarines and their intelligence collection operations. Former crew members were authorized to discuss some aspects of the missions. And, gradually, the story emerged of American submarines that had entered Soviet harbors at night, collected intelligence that couldn't be obtained any other way, and withdrawn without detection. Those operations will never be fully understood outside the classified channels where their intelligence products were analyzed. The specific capabilities of the submarines, the precise details of the intelligence they collected, and the comprehensive scope of operations conducted over decades remains secret. But the fundamental achievement is clear. American submarines conducted intelligence operations inside Soviet territorial waters, so aggressive they bordered on acts of war. They approached within visual range of the USSR's most heavily defended naval facilities. They collected information that informed American strategic planning at the highest levels, and they did it successfully, mission after mission, year after year, throughout the 1980s, until the Cold War's end made such dangerous operations less necessary. That achievement represents the ultimate expression of submarine capability, the ability to go anywhere in the ocean, collect any intelligence required, and return safely despite every defensive system an adversary can deploy. It's a capability that required technological superiority, professional excellence, and courage that few military operations in any era have demanded. The submarines that conducted Operation Winterwind and similar missions demonstrated all three. They operated in defended waters. They collected intelligence under conditions where detection meant international incident or potential military confrontation. And they succeeded because American submarines and the men who crewed them were simply better than the Soviet forces attempting to defend their own territorial waters. That reality, established mission after mission throughout the 1980s, helped convince Soviet leadership that competing with American naval capabilities was impossible. It contributed to the economic and military pressures that eventually led to the Soviet Union's collapse. And it remains a testament to what submarines, properly employed by skilled crews with political support, can achieve even in the most dangerous operating environments imaginable. The intelligence operations conducted by USS Posh, USS Richard B. Russell, and other special mission submarines during the 1980s will remain among the most aggressive and successful espionage missions in American history. They were operations that existed at the very edge of acceptable risk. They were conducted by submarines and crews that represented the absolute peak of naval capability, and they collected intelligence that helped win the Cold War without firing a shot. That achievement deserves to be remembered, even if most details remain classified decades later. The submarines that entered Soviet harbors at night proved that American forces could conduct any mission, in any location, against any adversary. They demonstrated that courage combined with technology and professional skill could overcome every defensive system. And they showed that sometimes the most important military operations are the ones that remain secret for generations after they're completed.